Now let's understand about the bulk modulus. What will happen? First of all, let's understand about the bulk stress and strain. So what will be happening in the bulk stress and strain? You will be having some body, something like this, and you will be applying some pressure. Actually, not you, but the liquid, or in whatever the liquid or body is being immersed. So that pressure will be from each and every direction, something like this, and that will be a perpendicular force. Now, what will happen because of this? You can see that you are applying pressure from all the directions, right? And now, when you are increasing the pressure, let's say initially the pressure was, let's say, P naught. Okay, and now you are increasing the pressure. Now you're increasing something and you are making it something else. Let's say there is a change of pressure a little bit, that is of del P. This is the change. Okay, and the new pressure which is coming out to be equals to P. So what is happening when you are applying the pressure from each the sides? It's not like that only the pressure is being increased. If you will increase the pressure, there will be a reciprocal effect on the volume. That is, the volume will be decreased. So what will happen if you are increasing the amount of pressure? Now what will happen? The volume of it will be decreased. It will be shrinked out a little bit, something like this. It will be shrinked out. Okay, so we see that when we are increasing the pressure, our volume is being decreased. This is what? This is the bulk stress. This del P, this del P is nothing but the bulk stress. This is the stress you are applying, right? Bulk stress. But what will be our change in the volume, or what will be our strain? The strain will be del V upon V. We know in this case this del V is decreasing, right? The volume is decreasing, the change is negative, hence we also have to apply a negative sign. So if I want to write the value for the bulk modulus, that is represented with B, how will we write it? First of all, what kind of strain is there? Is it parallel? No, it's not parallel, it is normal. So we will write normal stress. And how will we represent this normal stress? This is nothing but change in pressure. We are changing the pressure in this case. Acha, change in pressure, you don't get confused that in the bulk modulus or in the bulk stress or like in the compressibility stress and all, we understand about force upon area. Then why are we talking about the change in pressure this in this case? Force upon area is also pressure only, so there is nothing different. Okay, so and what about strain then? In this case there will be a volumetric strain. Why volumetric strain? Because you see volume is changing. So what will we write? We will write del V upon, over here we can write V naught, or over here only you can write V. This is the initial, V naught is the initial one, and the del V is the change. Okay, now I will place a one thing over here, and that will be this negative sign. Why I'm placing this negative sign? Again, I'm saying this. We are placing this negative sign because we want to represent that our pressure is increasing. And if our pressure is increasing, our volume is decreasing. To represent this thing, we are applying a negative sign over here. And it means that our bulk modulus value will come out to be negative. But is actually the bulk modulus negative? No, bulk modulus is not negative. This negative sign is just representing that if you are increasing the value for pressure, the value for volume is decreasing, or volume is negative. Okay, so this is our bulk modulus. Now what is compressibility? A new thing come over here. It was not in the Young's modulus, it was not in the Scher modulus. What is this bulk modulus? This is nothing, very simple thing, very simple thing. If you will reciprocate this bulk modulus 1 by B, it will just, you will just reciprocate, then you can write it as negative del V upon V naught upon del P, and this will be called as the compressibility. Very simple, just opposite. Acha, if we talk about the unit, in this case, what will be the unit? See, this is unitless quantity, that is del V upon V, unitless. So there was only the unit for P. What was the unit for pressure? It was Pascal, or you can say Newton per meter square, or you can also say ATM. But in this case, if we will talk about the unit of compressibility, what will be the unit? It will be Pascal inverse. Why? Because it is in reciprocal, or we can write that it will be ATM inverse. These will be the units for the compressibility. Okay, see, if now let's do this question. So if we are going to do this question, first you have to have a little knowledge that how do we find the pressure in the case of liquid. So it, in this question it has been given to us that the depth is what? The depth of the Indian Ocean is about 3000 meter. We need to find the fractional compression. We need to find this del V upon V of the water at bottom of the ocean, right? Given that the bulk modulus of the water is this. Okay. Now see, The given thing I have highlighted, or we could say the, okay. Now see, if we want to find del V upon V, obviously we cannot find the change in volume and volume of the ocean in this case. But what we can do is, we know one formula, that is bulk modulus is equals to stress upon strain. Or instead of strain, I could also write del V upon V, because this is the value for strain. Okay. Also, we can do one thing, that what is this stress? It is nothing but the pressure, right? As I have told you in the previous case also, that it is what the pressure is being applied, right? The pressure, that force upon area technically. So this is what? It is force upon area, or you could simply say pressure. Why am I referring to the pressure? Because see, I will tell you why I'm referring to the pressure just after a minute. So in this case, if we want to find the force upon area, we won't be able to find, again I'm saying, but we can find the pressure in the case of the liquids. So there is one formula which we use to find the pressure in the case of liquids, that is rho GH. Rho GH. This is the formula which we use numerous times. Okay. How are we going to apply it over here? First of all, let's talk about the value for G. What should be the value for G, which is the very simple, everybody knows that what is the value for G. It should be equals to 10, right? Gravitational acceleration. Okay. Then what should be the value for H in this case? Is the height given to us? Yes, height is given to us, and that is, this height is given to us, that is 3000 meter. Okay. And what about this rho? What about this density? In the case of water, we can take it as 1000 kg per meter cube. And why I'm saying kg per meter cube? Because I can see everything in as a SI, meter, Newton per meter square. So we will take kg per meter cube. Let's put one by one each of the values. So first of all, the rho, that is 1000. I'm writing the units also, that is kg meter per meter cube. Then what about this G? G we can take as 10, and this is gravitational acceleration. What should be the unit? Meter per second square, acceleration unit. Then what about this H? Height is given as 300 meter. Now when you will solve it out, you can see that there is only one 3, and you can just add up the 6, then and 1, that is 10. So it should be 3, 10 power 7, and it is pressure, right? So either you can write Pascal, or you can write a very simple unit, that is Newton per meter square, and this is our pressure value. Now let's come back to this formula, that was B is equals to stress upon the strain. The bulk modulus is already given of the water, and that is equals to, I'm using this formula, I'm substituting these values in this formula now, that is 2.2 multiply by 10 power 9. This is the bulk modulus. What about the stress? The stress is just this pressure, right? Force upon area. And this value is 3 multiply by 10 power 7 Newton per meter square. What about the strain? Strain is something we have to find. Del V upon V is something we have to find. I'm writing it over here now further on this side. So if I will take my del V upon V on the other side, I can write it to be equals to 3 into 10 power 7. Achha, what should be the unit of the bulk modulus? It will be also Newton meter square, given in the question as well. And then it will be 3 multiplied by 10 power 7 Newton meter square. And what about this bulk modulus? This will be 2.2 multiplied by 10 power 9 Newton meter square. Why I am focusing on the unit is because we know that this unit, that is del V upon V, is a unitless quantity. And here you can see on both the side, as numerator as well as denominator, the values of the units are same. We can cancel it up and we can find out that this is equals to nothing. It's a unitless quantity. These will be cancelled out. Okay, now you can solve it out, and when you will solve it out, you will find a value, and that will be equals to 1.36 multiply by, you will take this 9 on the top, so it will be converted into negative, and that will be equals to 10 power minus 2. What will be unit? No unit. It's a dimensionless quantity, and this is how you will find the value for fractional compression. Is this clear? So see, this simple the bulk modulus was.